Today, we will discuss the node analysis. Let us see the definition of a node analysis here. Definition: nodal analysis, or also known as a node analysis, it is a method that provides a general procedure for the analyzing the circuits using a node voltages as the circuit variables. So you should keep 3 points in your mind. So node analysis means it is a procedure. It is a procedure for circuit analysis. And key point is the node voltages. Okay. So a node analysis, it is a procedure. It is used to solve the circuits using a node voltages as the circuit variables. Nodal analysis. Node analysis, it is also called as a node voltage method. Okay. There are 3 words: node analysis, nodal analysis, or else node voltage method. They are one and the same. It is a procedure. It gives a solution. It gives a solution for the analysis of the circuits using a node voltages as the parameters or a circuit variables. Right? Features of node analysis. The node analysis is based on Kirchhoff's current law, KCL. Node analysis, it is based on KCL. We know KCL is at any node, summation of incoming currents are equals to a summation of outgoing currents. We know it. Or else algebraic sum of currents at any node is 0. Node analysis is based on KCL, right? Having n nodes, there will be n minus 1 simultaneous equations to solve. The meaning of it is, in any circuits, if there are 5 nodes, then there will be n minus 1, 5 minus 1, 4 simultaneous equations. Hopefully, if there are 4 nodes, then there will be 3 equations. That is the meaning of the second point. In node analysis, we do consider voltage as a variable. In node analysis, if we do have n nodes, then there will be n minus 1 simultaneous equations. If there are 4 nodes, then there will be 3 simultaneous equations. All right. Next point. Solving n minus 1 equations, all the node voltages can be obtained. The meaning of it is, there are 4 nodes, so that there will be 3 simultaneous equations. If we do solve these 3 simultaneous equations, then we will get 3 values. They are nothing but voltage at a specific nodes. Hopefully we have understood it. Means let us solve n minus 1 equations. A result of it is node voltages. Result of simultaneous equations gives result of solution of simultaneous equations give values of node voltages. All right. Hopefully you have understood it till these 3 points. The last point is, a number of non-reference nodes is equal to the number of nodal equations that can be obtained. You will come to know what you mean by the non-reference nodes. Here, the fourth statement is, a number of non-reference nodes are equal to number of non-reference nodes are equal to a number of nodal equations. Nodal equations are nothing but simultaneous equations, right? We will come to know the meaning of a non-reference nodes. Number of non-reference nodes are equal to a number of nodal equations. That is nothing but a number of simultaneous equation. Right? So till now, okay. So I conclude here. Node analysis, it is a procedure. It gives a procedure for the solving the circuits. The key point is node voltage is as a variable. KCL is used. If there are n nodes, there will be n minus 1 simultaneous equations. If there are number of simultaneous equations are equals to a non-reference nodes. These are the conclusions till now. Okay, next point is, could you see? There are two types of nodes here. There are two types of nodes. That they are a non-reference node and a reference node. What do you mean by non-reference node here? It is the node which has a definite node voltage. Hopefully you got the meaning of non-reference node here. It is a node which has a definite node voltage. For example, here, consider this a circuit. Consider this a circuit. Can you tell me how many nodes are there in this circuit? The answer is 3. Answer is 3. This is node 1. This is node 2. This is node 3. In any circuits, these nodes are classified into two nodes. One is a non-reference node and a reference node. Out of 3, some will be non-reference and some will be reference nodes. The meaning of non-reference node is it is a node which has the definite node voltage. For example, node 1 and node 2 are the non-reference nodes here. It is node 1, it is node 2. These two are considered as a non-reference nodes because they do have a definite voltage. Then meaning of a reference node. It is a node which acts as a reference point to all the other nodes. It is a ground. Usually, ground is taken as a reference node. Other than ground, the remaining nodes are a non-reference nodes. Number of non-reference nodes are equal to a number of simultaneous equations. Hopefully, you have understood it till now. All right. Types of reference nodes. It may be a chassis ground. The symbol is like this. It may be earth ground. The symbol is like this. So we have said in any circuits, nodes are two types, a reference node and non-reference node. A reference node can be of two types, that is a chassis ground, the symbol is like this, and earth ground, the symbol is like this. In most of the cases, we do use this symbol as a reference node symbol. All right. So in this circuit, we do find 3 nodes, 1, 2, 3 as the nodes. Out of these 3, 2 are the non-reference nodes, node 1, node 2, and this node is considered as the reference node. All right. Based on this concept, let us see how to solve any circuit using node analysis. And already we said it is nothing but a procedure. Node analysis is nothing but a procedure to solve the circuit. Means, what could be the first step in node analysis? The first step itself, select a node as a reference node, assign voltages V1, V2 till Vn minus 1 to the remaining nodes. The voltages are referenced with respect to the reference node. Consider any circuits. Your first task, work, duty is to identify the number of nodes. After identifying number of nodes, select one node as a reference node. Give that node as a reference node and give V1, V2, V3 and so on to the remaining nodes. It is the first procedure. Then what is the rule for selecting a node as a reference node? In which you can select, it can also be a reference node, then these two will be non-reference. It can also be a non-reference node. At that time, these two will be non-reference node. The a simple procedure to select a node as a reference node is, it is a node where more number of branches should be connected. So what is the procedure to say the node as a reference node? It is a node at which more number of branches should be connected. In these three nodes, in these three nodes, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 3, 4 branches and 3 branches. Even you can consider this is also as a the reference node. No problem if it is selected as a the reference node. Okay. So the next point is, what is the first procedure in node analysis? Identify the number of node, select one as a reference node and remaining as a non-reference node. All right. Later, apply KCL to each of the non-reference nodes. The second procedure is apply KCL to each of the non-reference node. All right. Here in this circuit, we need to apply two KCLs because we do find here two non-reference nodes. The third point, use Ohm's law to express the branch currents in terms of node voltages. What is Ohm's law here? The Ohm's law is V equals to I into R. So after applying the KCL at non-reference nodes, convert I in terms of V by R format. All right. So while applying the Ohm's law, node always assumes that the current flows from a higher potential to the lower potential in a resistor. Hence, current is expressed as follows. When node is assumed, always assume that it is at a higher potential. It is at a higher potential. When while applying KCL at node V2, assume that V2 is higher potential compared to the remaining nodes. That is said in the third procedure. That is, the current always goes from it is the difference of the voltage between high level voltage and the low level voltage divided by the resistance. That is said here. You will come to know the meaning of the third one later. After applying KVL, after applying Ohm's law, then after the application of the Ohm's law, we'll get n minus 1 node equations in terms of node voltages and the resistance. Then simplify them, solve n minus 1 simultaneous equations. Okay. So the first step is, I do conclude the steps of node analysis. The first one is identify the number of nodes. Second one, apply the KCL. Third one, apply the Ohm's law. Fourth one, get the n minus 1 simultaneous equation. A fifth one, solve those simultaneous equations to get the node voltages. All right. Keeping all these points in our mind, let us solve a simple example here. Here, the circuit is there. The meaning of this symbol is circuit is continued. We don't know what is there after this. The meaning of this symbol is circuit is continued. We don't know what is there after this symbol. Okay, it is not end, but there is some more circuits are there. The meaning of this is, all right. So let us consider only this part. Let us consider only this part. What is first step? Identify the number of nodes. Can you? Answer is, there are 4 nodes. The first node, the second node, all together one node, all together one more node. There are 4 nodes. 1, 2, 3, 4. All right. There are 4 nodes. Okay. The right answer is there are 4 nodes. All right. So please correct your answers and follow the concept. All right. The next thing, we have identified the number of nodes. Now, what is second step? Apply KCL at each node. Apply KCL at each node. Let us apply KCL at node 1. What is KCL here? KCL is nothing but summation of incoming currents are equal to a summation of outgoing currents, and also number of currents are equal to a number of branches. So how many branches are connected to? How many branches are connected to node 1? I say 1, 2, 3, 4 and 5. Hopefully you have understood it. So number of branches are connected to node 1. They are total of 5 branches. That means there should be 5 currents. All right. So, and one more assumption is, while applying KCL at node 1, assume that it is at a higher potential. Assume that it is at a higher potential. All right. So, as a result, how many currents will be there? Current through R2, current through R1, current through R1, then a current source of value I, current through R3, current through R4, that should be equal to 0. That should be equal to 0. And we have said that always it is at a higher potential. That means assume that all currents are leaving the node. It is what the procedure here. Assume that while applying the KCL at node 1, assume that all currents are leaving the node. If that is the case, means all values will be positive here. Okay, but see here, it is a current source which is opposite to our assumed value. We have assumed that the current is leaving the node, but it is entering towards the node. That's why instead of positive value for this current source, it should be the negative value. All right. So it is positive and it is a negative value. So simplify this, what will get? So this I will come towards right side. Okay. Next. After applying this, what is third step? The third step is use Ohm's law. Express the current in terms of only voltage and the resistors. All right. So voltage at this node, at this node, at this node, it is V1. What is total voltage of this complete branch? It is nothing but V1 minus V2. Total voltage of this branch is V1 minus V2. What is current? Current equals to V by R. Total voltage of this branch is V1 minus V2 divided by resistance R2. So that the current through R2 resistance can be replaced by V by R. What is total voltage of this branch? V1 minus V2 divided by R2. Hopefully you have understood it. Now, what is total voltage of this branch? Total voltage of this branch is V1 minus a reference voltage. Always the reference voltage is treated as a 0 volt. V1 minus 0 divided by R1, that is written here. What is current through R3? The current through R3 is total voltage divided by total resistance. Total voltage is V1 minus 0 divided by total resistance. V1 divided by R3. All right. Next, current through resistance R4. We do find two voltages here, V1 as well as V3. Total voltage of this branch is V1 minus V3. Total voltage of this branch is V1 minus V3 divided by R4. That is written here. Later, so it is written a positive value at the RHS side because of this assumption. Hopefully you have understood this concept. So we are not solving it completely, but this problem is taken to understand how to identify the number of nodes. After identifying, one should be selected as the reference node, then apply KCL at each node, then convert the current in terms of voltage and the resistor. So can you reply? Have you understood how this equation is written? Good.